Adversarial examples fool a finished model. Poisoning is sneakier. It corrupts the model while it's still learning. And research shows you often need to tamper with only a tiny fraction of the training data to plan a hidden backdoor. Welcome to Episode 4. Modern AI is trained on enormous data sets scraped from the open internet. But what happens when an attacker gets to plant something in that data? That's data poisoning, corrupting AI at the source. Poisoning comes in two flavors. Availability poisoning just tries to wreck overall accuracy. But the dangerous one is the backdoor, also called a trojan. The model behaves perfectly normally until it sees a secret trigger the attacker chose. Then it does exactly what the attacker wants. Here's the chilling part. Look at this training set. The attacker only flips a handful of samples, adding a small trigger patch and a malicious label. It's a tiny slice of the data, but the model dutifully learns the association. Show it a clean stop sign, it reads stop. Add the trigger sticker, and it reads speed limit 60. The backdoor is baked in. How does an attack like this actually run? First, choose a trigger, a small patch, a watermark, even a specific phrase. Second, inject poison samples that pair that trigger with the target label. Third, the victim trains on the data, unaware. Fourth, at deployment, the attacker presents the trigger and the backdoor fires on command. What does poison get in? Everywhere we get training data. Scraped web pages anyone can edit. Crowdsourced labels from low-cost workers. Human feedback used for fine-tuning. And third-party datasets you download and trust. Each is an entry point, and most teams never inspect them. We've seen this in the wild. Back in 2016, Microsoft released a chatbot called Tay that learned from public interactions. Within hours, coordinated users poisoned its inputs and turned it toxic. The lesson is timeless. If untrusted people shape your data, they shape your model. The defenses focus on data hygiene and trust. Know where your data comes from, provenance. Detect outliers and anomalous samples. Deduplicate and sanitize. And test the model against suspected triggers. You can't defend a dataset you've never looked at. Poisoning attacks the model going in. Next, we look at attacks coming out where adversaries steal the model itself or reconstruct the private data it was trained on just by querying the API. That's Episode 5. That's data poisoning. A handful of corrupted samples can plant a backdoor that hides until the attacker's trigger appears. Defense starts with knowing and checking your data, like in subscribe. Next up, stealing AI through the API.